Hey, welcome everyone, and thank you so much for joining us for our final Earth Month webinar, Fringe Benefits Restoring New Jersey's Salt Marshes. My name is Lily Mullock. I am the marketing coordinator for the Nature Conservancy in New Jersey, and I'm very happy that you could join us for this exciting webinar. We'll be hearing from Adriana Zito Livingston today, our New Jersey Nature Conservancy Climate Adaptation Project Manager. Next slide, please. All right, as always, before we begin, I have to go over a couple of housekeeping items. We have live captions enabled for this webinar. To access them, just head down to your Zoom toolbar and click the button labeled CC Live Transcripts. From there, you can turn the captions on or off. You can also do things like adjust the font size and color, and you can also translate the captions to the language of your choice if needed. At the end of the webinar, we will have time for a Q&A session with Adriana, so please make sure to add your questions to the Q&A feature throughout the presentation. And then lastly, we will be recording this webinar. A link to the recording will be sent out in a follow-up email that you can expect to see sometime next week. And with those items out of the way, I'm happy to introduce you to today's speaker. Next slide, please. All right, so let's get to know Adriana. Adriana began her career with the Nature Conservancy in 2010 as a seasonal environmental educator at South Cape May Meadows Preserve. She joined the chapter's lands team at the beginning of 2011 to oversee South Cape May Meadows and assist with habitat management, volunteer coordination, and facilitating public access on TNC preserves. Adriana then joined the chapter's coastal team in 2013. She now sits as our Climate Adaptation Project Manager, where she works on the planning, implementation, and monitoring of coastal restoration projects. Prior to TNC, Adriana worked for the Florida Fish and Wildlife Conservation Commission, conducting underwater monitoring and surveys for commercially important shellfish. She has a bachelor's degree in biology from Wittenberg University and a master's in biological science from Clemson University. And now that we've gotten to know Adriana a little bit better, I will turn it over to her to get started with today's featured presentation. Take it away, Adriana.
Thanks, Lily. Really excited to be here today and to be able to share New Jersey's salt marshes with you. So as Lily said, I started my career underwater as a marine ecologist in Florida, and very excited to be having worked on the land now for 16 years in New Jersey. So a little bit about the Nature Conservancy. We are the largest global nonprofit conservation organization in the world. We have many staff. We've conserved a lot of land on land and in the water. We operate in over 80 countries and territories. So we're a global organization that acts locally. And this organization, we work in concert. So we're all over the world, but we're all working towards the same goals. So our current push is towards goals that are grounded in 2030. There are a number of them, and you see them listed here. Primarily, our coastal salt marsh work fits under this final goal, which is to use nature to help 100 million people at severe risk of climate-related emergencies like fires, floods, fires, and droughts. And so our coastal work is a small piece of that, but a very important piece. And so I'm excited to be sharing it with you today. Here in New Jersey, the New Jersey chapter, we've been working in this state since 1955. We have around 50 employees, depending on if we have seasonals or not. We have offices in southern New Jersey, in Woodbine, and also in Chester. We protected over 62,000 acres in the state of New Jersey. And I've had the benefit in my career to work on our lands and waters teams. So those global goals for 2030 touch down here in New Jersey with our own state goals. Our coastal work, again, fits under climate adaptation and coastal resilience. And so we're using nature-based solutions to keep salt marshes in place. We're focused on restoring 2,000 acres of salt marsh and benefiting over 100,000 people from the impacts of climate change. So we have a lot of acres of salt marsh here in New Jersey, over 200,000 acres. Beautiful salt marsh meadow, like you see in the picture here. Those marshes are located along our coast. As the title suggests, they really fringe our state. And so I have this kind of zoomed out version of our state. Blue and green, I think, can be challenging to see together, but you can see the green all along New Jersey's coast, more heavily in the south, and the turquoise in this second map. So really, our salt marshes historically existed all along New Jersey's coast at that interface of land and water along our back bays. They remain primarily along the Delaware Bay and the southern, not the southern half of the Atlantic coast. We have really extensive salt marshes considering the heavy development of our state. And salt marshes are very important systems. So they provide nursery habitat for wildlife. So in these images here, just quick round robin, we see rays that feed in the shallows on shellfish and clams. We see blue crab, which are very tasty and very feisty, if anyone's encountered those. Sharks actually utilize our salt marshes and those nearshore waters for having their pups and starting their lives. And then, of course, flounder are another important piece. And then there in the middle, you see the quahog clam. So even when the areas in our coastal waters look like it's just mud, there's lots of life teeming underneath the surface. All of those provide a very complex food chain for animals like birds and predators like sharks. So a lot of the seafood that we enjoy and that our commercial and recreational fishing industries are bounded on begin their life or spend a significant portion of their life in our salt marshes. These are incredibly productive systems. Marshes also are amazing carbon storage sinks. So the plants of the salt marsh grasses. So marshes are made of plants by plants. So not just the leaves and the structure of the plants, the salt marsh grasses themselves sequester carbon, but they actually store a lot of carbon in their roots and create a really thick, rich peat layer that is the foundation, the surface, and the platform of our salt marshes. And all of that represents hundreds of years of stored carbon. Salt marshes also provide an incredible buffer to coastal communities, businesses, and upland habitats. You can see in this image, kind of top and bottom, the value of salt marsh plants to buffer and slow down water to reduce the impacts of flooding. And so a good visual for this is salt marsh plants are like a shag carpet. So they provide kind of that upright, shaggy kind of substrate. And when you're rolling a marble across a shag carpet, it slows down because of that drag. And so a vegetated salt marsh functions much in the same way as a marble going across that going across that shag carpet. So the wave is coming in, it encounters a vegetated salt marsh, it loses energy, and impacts are less severe. So these provide really important shoreline protection, especially in the face of storms. So our salt marshes are super important. They're found throughout our state, and they're in trouble. So salt marshes are on the front lines of changing climate, which includes rising water levels, both from storm events, flood tides, and extreme weather events, so wind-driven water inshore. This is an image at one of our upcoming restoration sites showing a really high water level stage. And you can see the impact of that here on the marsh. Other challenges, so those are kind of the natural challenges. Other challenges our salt marshes face are coastal development. So people have long since been drawn to the shore for recreation, commerce, aesthetics, and New Jersey has a very developed shoreline. So a couple of things, I'll just unpack this image because I think it's a really apt snapshot of New Jersey. So to the right, we see obviously coastal development, a lagoon community, near Beach Haven. You see the canals and all of the boats and homes, right? So that concrete structure, a very heavily developed coastline. A quick juxtaposition, a stark juxtaposition to the protected land, the salt marsh to the left. So just across that canal. To the untrained eye, I guess, or at first glance, you think this is a green area, it is a natural area, and you're not wrong. But you can also see human impact if you look closely on this image. And I'm hoping you can see my mouse. There are a number of signals of human impact on our salt marshes, and this is a signal that can be seen on aerials kind of throughout New Jersey. So we see these linear mosquito ditches used to drain salt water off of the marsh for mosquito control primarily, but it's also done for farming. So initially, using linear ditches to get water off of the marsh was a standard practice back in the Citizens Conservation Corps days. The next mosquito practice was to actually make big ponds and connect them together. So if you see kind of this little, almost looks like somebody went tooling around in the marsh, because they did, to do open water marsh mosquito management. And then these are actually earthen berms. So these kind of raised areas all along the perimeter of the marsh. So human footprints have been in our salt marshes as long as we've been living on our coast. And what we're seeing now is an interplay between the coastal development, ditching, and the channels, and rising sea levels and increasing storm severity. So we're seeing our marshes reach concerning thresholds much faster because of this kind of 1-2 punch of develop and impact, and then severe environmental hazards. And what we see on the marsh surface, so this is a zoomed in image, the marshes are drowning. So the marshes are drowning from the interior. They can't keep pace with sea level rise on their own. Salt marsh plants and salt marsh grasses are really incredible at their ability to handle high water level periods and low water level periods. When those trends are predictable and minor. What we're seeing now in the face of rising sea levels or rising water levels, plants are spending too long underwater, so in a flooded state. So when the water is higher than it is in this image. So right now, they're fine when water's around the roots, but once the water rises and covers a larger portion of the leaves, they're less able to do photosynthesis, they're less able to grow, and we see a point beyond which the plants can't survive certain levels of water. And we see this conversion that you see in this image, right? So there's living plants and then areas of expanding interior open water and mud. And as if that weren't enough, salt marshes are also being lost significantly throughout the state from the edge. And this is due to storm surge, waves, and boat wakes. So all of those things work together. Waves lapping against the shore, one tide at a time, one boat wake at a time, taking sediment away. And we see the marsh actually, if you can see my hand, essentially the waves are carving out from the base of the salt marsh to the point where it collapses. And we start to see chunks falling off of the marsh. So it happens by inches until it happens by feet. And so this signal is also happening all around the state. We're losing many acres from the edge. And what this looks like at scale or in places you might be familiar with is this really rapid, so marsh loss from the edge is this really rapid march landward. So out here in 95, this is the Rutgers Marine Field Station in Tuckerton. And you can see really quickly from in the 20 years that are shown in this image, how quickly the shoreline is lost. In the Delaware Bay, this is very similar. The red red dots on the image to the left are in the 30s. Those are the same points in the image on the right in 2015. So really significant acreage loss. In Barnegat Bay, which is an area where some of our upcoming work is focused, 27% of the marshes have already been lost, and that was just between the 1880s and 1972. And that trend has continued. I just want to show another signal of kind of salt marsh degradation that's, I hope, easy to understand from this image. So this is the grass where the salt marsh is already like drowned, right? So pieces of the marsh have fallen off and are sitting here in the water on the bottom. And then we see that kind of that open mud. So those are the areas too wet, too low, or too energetic for the plants to continue to live and thrive. We also see this stunted salt marsh grass. So it's not that healthy, happy, tall salt marsh grass that we've seen in some of the other images. It's this stunted kind of wave impacted or drowning. So these are think in a trajectory of going, gone. This is in the middle. This is going, and the next step is open water conversion. So as I said, this is a problem that's been happening for a long time. The rate at which we're losing our marshes is increasing, and that trend is expected to accelerate going forward. So in this map from a study, and this is in the Delaware Bay, just to orient you. You see, I think two of these colors. So the current condition, so this kind of I guess slate gray shadow, is the current extent of the salt marsh in Delaware Bay. And with only 1 foot of sea level rise, we get all the way inland to where you see this rim of red and maroon. And then that trend only gets more intensive as we see increasing rates of sea level rise or increased inundation. I point this out in the Delaware Bay in part because Delaware Bay, when compared to the Atlantic coast of New Jersey, has considerably less development. This is not, the Delaware Bay has some hardened shorelines, but primarily there aren't barriers, as we would call them, to marshes moving inland, which is how they respond to sea level rise. The plants just keep kind of marching inland until they reach a barrier. And on the Atlantic coast, so this is kind of best case scenario, unimpeded marsh migration inland in the Delaware Bay. On the Atlantic coast, we hit the parkway pretty fast, and some of those roadways and infrastructure. And so we get what some of us in the industry call coastal squeeze. So the marshes, the remaining marshes, are really stressed from all sides, and that requires some solutions. So these habitats are too important to lose, and we know from study kind of what some of these drivers are to marsh loss, and we're in a position to be able to intervene and hopefully keep more of these marshes in place so that they can keep serving us. One of the ways that the Nature Conservancy has been working for the last decade to find a solution that's kind of at the scale of the problem for salt marsh loss is working to help the marshes keep pace with sea level rise by adding clean dredged sediment from boat channels. So all of our channels along the coast, whether they're maintained by New Jersey Department of Transportation as a state channel or the Intercoastal Waterway managed by the Army Corps of Engineers, they all require maintenance, especially after big storms. Sediment is moving around in these systems all the time. It's actually the lifeblood of the salt marsh. Historically and conventionally, the material that was dredged from the bottom of the channels was considered dirty and a waste product, and it was removed from the habitats along our coasts for concerns for public health and wildlife health as well. So we've come full circle with a practice that's testing that material, and when it's clean, being able to utilize it and bring it onto the marsh platform to raise elevations. And so we're calling that marsh replenishment. So think about how our how our beaches in New Jersey are maintained actively through dredging sand and bringing it onto the beach to keep those beaches in place for recreation, for wildlife. This practice is marsh replenishment in the same way. So taking the material from elsewhere in the system and relocating it back onto the marsh surface. So it's really important to emphasize that this material is tested and is clean enough to be used for this this practice. That's obviously the first concern. And so we're working not just on the ground, but at scale to help make this replenishment happen in many of the areas that our marshes are struggling throughout the state. Just going to go back to this last image really quickly. So while this channel, the Intercoastal Waterway here in Cape May County, is being dredged, that material is being pumped and piped onto the marsh platform to raise it up. And this is what it looks like from the sky. So that direct placement onto the marsh platform, you can see really clearly in this image, all of this bare ground is newly placed sediment to raise the elevation in an area where you can see this untreated area here. This marsh was breaking apart from the interior. Too wet, too long, plants were dying, and it was expanding. And so the intervention here in Avalon was to add sediment, to add elevation, to get those plants kind of back to their happy tall place. So making this practice, getting the scale of the solution to match the scale of the problem requires cooperation, kind of a unconventional partnership. I think some of the best work we do at the Nature Conservancy is the result of these unconventional partnerships of what if we tried this? And so after Hurricane Sandy, there was federal funding to be able to provide marsh restoration efforts. And so we partnered with DEP to bring navigation, so the dredging partnered with conservation to pilot this restoration technique of marsh replenishment. As we go forward, identifying areas where this practice can really take hold, and as we're building processes to streamline, we're looking at the nexus of marsh needs, so marshes in trouble, community needs, because again, communities benefit from having the protection of marshes, and then dredging need. So how can we capitalize on available material? Where is the dredging happening? Can we co-locate restoration? So again, this is a really unconventional practice, but it's been done in many places. So this is, again, in Cape May County. Just wanted to walk you through what this looks like in practice. So dredging usually happens over the winter. It might be why you've never seen a dredging project happen, even if you spend time along the coast. But as the dredge, this little blurry boat over here is essentially shop vacuuming the material out of the bottom of the channel. It is going into a pipe, just like a vacuum hose. And so that pipe, actually, if you follow my mouse, goes kind of over the marsh, under the channel, and along this marsh edge to deliver material mixed, so it's water mixed with mud or sand. And that slurry is what is being used to raise the elevation of the marsh. So this is a lot like a construction project as far as restoration happening. You see people monitoring. Technologies come a long way, and they can actually look at elevations and how much material is laying down where, using drone technology and a variety of other advancements to make sure we get the marsh platform back to the place where the salt marsh grasses can take hold and continue doing their thing. And so the practice, in practice, this is harder than it makes a lot of sense. It's work worth doing, but we've really been partnering and trying to better understand the navigation industry and navigation opportunities and how we can match those with restoration opportunities. So there are, in addition to having 200,000 acres of salt marsh in New Jersey along our coast, there is a complex network of boating channels. So the Department of Transportation has over 300 miles of state channels that they manage on a regular basis. The Army Corps of Engineers manages another 120 miles, mostly the Intercoastal Waterway. And there's also a great number of local and private channels. So once we get into lagoon communities and those channels and canals, there's even more local dredging needs that has yet to be quantified. And this means that there's a wide, there's a high potential for this to be adopted. So if we can figure this out, we can do it in a lot of places relatively quickly. We've been taking the time to build the enabling conditions and to get it right. So this is another image of Avalon. You see the proximity of our human communities to our marshes, and you see the boat channel network that actually goes within, around, and between our salt marshes. So how are we doing this, right? I alluded that it's a difficult thing. It's a challenge bringing these two worlds or three worlds together, depending on how you look at it. We started with scientific study, so really assessing the marsh acres. This was a study we did with Stockton University, looking at marshes in need. So what is the ditching? Where's the edge loss? Kind of broad brush across the entire state, doing this desktop analysis. And then looking at sediment availability in just the state channels. Those were we started small, and really seeing how out of whack those numbers were, to build the case to get this right and to activate as much sediment for marsh restoration as possible. So focused on scientific study, creation of resources, so communicating the importance of our salt marshes and the potential for this practice is another body of work where TNC has created a lot of time, a lot of resources, and spent a lot of time and energy, including mapping tools to help for nature-based solutions and marsh restoration as a whole. There's a lot of fantastic mapping tools that TNC supported the development of that can really guide this work going forward and moving towards projects. Innovative partnerships. So this is a really fantastic day on the marsh near Atlantic City. You see the Rebel Casino here in the background. There's staff from the Army Corps of Engineers, not just in the Philly district, but actually folks from their research corps here, sharing lessons and a vision for the site with New Jersey Department of Transportation staff. You see DEP is there as the landowner, and TNC and some of our academic partners are there, kind of trying to bring it all together. And this site visit actually resulted in 2 different dredging projects contributing to a habitat restoration vision for Boot Island. Some of the initial placement was done last winter, and we're planning more work that'll be coming up in fall, actually. So innovative partnerships lead to action and make the help us advance the practice really quickly. We also need forward-thinking policy. So this was an occasion that I had to speak to some of our senators about the potential and the impact of the value of our salt marshes, and then the importance of being able to take swift action to protect and sustain them. So we need to be able to look ahead, think ahead, plan ahead, to keep these important resources in place. And we've done a number of projects. So I showed some images earlier of the Avalon site. But really, there's this first phase of like proving that this could happen. So we're bringing these disparate industries together. And can we even do it? What does it look like? And so there are 4 sites that were kind of in this first cohort of pilot projects. Just, can we even do it? What's it going to take? And how's it going to go? So these projects were really focused on proof of concept and really just mapping out broad brush how these projects can come together so that we can continue to refine and improve them going forward. So there's a project on the Delaware Bay at Fortescue, 2 at Avalon and Ring Island, and then at a project up at Edwin B. Forsyth National Wildlife Refuge at Good Luck Point. So in these pilot projects, I mentioned the Avalon project. It's about 40 acres of salt marsh. So these aren't postage stamp kinds of levels of projects. This is a lot of material being added to the marsh surface to get real uplift and impact. So you can see the progression, right? So right after the sediment was added, like through that hose that I showed you earlier, We see vegetation burial, we see a lot of bare ground, and it's not a single layer, right? But it's not a paved parking lot. Material is adding on top of the existing marsh structure in in varying layers. And this area also had pools that were being filled with material to bring it back to a more contiguous, healthy marsh platform. Things bounced back relatively quickly. And again, this was the second project that we did of this type. So it was a lot of learning and some educated guessing as to what the right elevations, how high do we need to go? How high is too high? How much tidal flushing do we need? All of those things that make really good salt marsh grass habitat. And the grass is really the foundation of these marshes. And so the whole goal is to get vegetation to come back. So after 2 growing seasons, you see it kind of filling in. And it's not today because I'm with you today, but about a year ago, this is what the marsh surface looked like out there about 10 years after the project was completed. So it can work. It can sustain elevation. It can sustain all of those important benefits that I cited earlier. So habitat, carbon storage, and wave attenuation. One other thing I'll point out in this image, just because it's really apparent, is the contrast between what used to be done with dredge sediment when the channels were cleared versus what the change we're making, right? So this innovation. If you look in the background of this image, you see this like mountain thing. That is called a confined disposal facility. It is an upland area that was created by dredge material. So under the practice and the guise that it needed to be out of the system, it needed to be away from tidal flow, away from wildlife. So this is kind of, in this image, you can see the contrast between the conventional way of managing dredge sediment and the result of this nature-based solution using dredge sediment to restore marshes. It's been really exciting to see how this practice has really grown. So we learned a lot. We did not get it all right the first time, but we learned a lot and we're able to make some adjustments. And now we have this second exciting cohort of projects. So I'll call them second gen projects. So we still see the green or the pilot projects, and then you can see the number since the pilot projects were completed, and about 2020 was a good luck point. We've seen kind of this rapid increase in scaling up of the number and variety of projects that are coming online using, these are all implemented projects, and apologies, there's another project over here. Thompson's Marsh was another project that was completed. So we're at about a dozen projects that have been completed in the state of New Jersey at this point. We're really starting to hone in on how to make sure these projects are successful, how to plan them effectively, cost effectively, and efficiently with our navigation partners. Really been able to focus on the alignment of the process. So all of these projects are amazing wins for conservation. They happened through sheer will and commitment from the navigation managers to the conservation managers to the landowners, people just willing to roll up their sleeves and figure a bunch of things out. And so I'm very proud and excited to see how this practice has come to be. One of the projects that's in, I will say, the third generation of beneficial use or marsh replenishment projects and efforts is we're starting to look at the interplay of solving multiple issues in a marsh, as many as we can with sediments because it's available, but really giving the marsh what it needs to bring it back to function. And so the projects that were just on the map primarily are beneficial use restoration projects. So whether it was at the edge or on the platform, really solely dredge sediment projects. The Lighthouse Center project is a project where we're working with a number of partners in Waretown to fix some hydrology where it's been messed up. So we've got ditching, and I'm getting ahead of myself. I think there's more images that will actually show this, but this is a project where we've got multiple issues and we're doing multiple restoration applications to address them, to see how we can really be holistic about maintaining these projects. So there's multiple issues at this site. As I just indicated, we see conversion to open water. There's an area that used to be contiguous salt marsh that just isn't. It's a big pond. It's a shallow pond, but it's a pond. So very little vegetation remains because of that drowning. We see really incredible edge erosion. So this marsh has actually lost 10 feet of edge in just the last 2 years. While we've been designing this project, the edge is marching inland. So it's a very clear edge issue. There's also this interior ditching and drowning. So if you see my mouse, we've got some linear cuts through the marsh. And when we zoom out, you'll be able to see kind of this network of ditches. And that's leading to areas where water is getting trapped and it's drowning those plants. And so we're seeing conversion. So it's got all the issues. And so working with partners, so Department of Transportation has been at the table from the beginning on how, and helping the conservation and habitat teams think through how to utilize sediment that they have available to address some of the issues that we're seeing. Not exclusively, but including sediment. So this green polygon you see at the top is that open water conversion area. That's an area that's going to receive sediment through direct placement to really rebuild the marsh platform so that to an elevation that salt marsh grasses will come back and populate. This blue polygon down here to the south is an area where historically there was a fringing beach at this property. And so this fringing beach really protected the marsh interior. And so dredge sediment is going to be placed along the shoreline here in a little bit of a polygon to reestablish that fringing beach habitat and provide interior marsh protection. And then this orange and red cell is the area where you can see all of these linear ditches, right? It's just crosshatched to heck. The ditches are going to be rerouted and remediated, and some of the areas where water is ponding, the water can be evacuated essentially. So you can use a shovel and make little man-made squiggly ditches that are called runnels that just help water reach a channel to find its way out. So we're addressing the interior drowning through that low-cost, low-tech technique that Ducks Unlimited and U.S. Fish and Wildlife Service have really been leading. So multiple partners, multiple restoration efforts, all in one site that's accessible by land on, it's part of the Upper Barnegat Wildlife Management Area in Waretown. The Natural Resource Education Foundation actually runs a center there, so this site is open to the public. So it's also going to be a platform and a place where people can see the impacts of and value of this work in real time. And so we're working with on the ground, creating projects, learning, sharing, building partnerships, aligning the process of restoration site selection with navigational dredging and that prioritization, and really looking whole hog at how we can make this a best practice. So how this can become business as usual for how dredge sediment is managed, because it's really the best shot that our salt marshes have. And so overcoming those challenges, working on enabling conditions requires work with our regulatory community, so regulatory flexibility. Regulations are actually put in place to protect the environment from any action. And so we've had a lot of really rich and exciting conversations about how restoration should be viewed through a different lens. And so those conversations have been going on for a very long time, but we're really excited, especially with the Sherrill administration, to have prioritized regulatory reform and permitting efficiency. So really actively engaged based on our on-the-ground projects experience and kind of a front row seat to those challenges. Excited to see some hope and some action to make these projects easier to do. And if they're easier, then they're faster and they're cheaper, which is a great thing. We have wonderful relationships with New Jersey Department of Transportation. I can't say enough about their Office of Maritime Resources. Really working on planning projects together and understanding their needs, what drives them, what makes a constructible project from their perspective, and matching that from the conservation side to really maximize sediment that's available. We're very fortunate in the state of New Jersey that most of our marshes are in public ownership. So they're owned either as part of the National Wildlife Refuge System by our federal government, or they're owned by the state of New Jersey, the Department of Environmental Protection, as wildlife management areas. And those folks are in every single conversation about how to scale this work. So they're bought in, they're participating, and many of the projects that I showed in that second generation map are projects led by state and federal partnerships on public land. And so that's been, I think, a huge win and a total game changer, understandably. We've been working at the Conservancy to fill some gaps, so to help assess sites and develop project plans and project concepts, so to get projects more shovel ready so that they're able to be implemented. And so we have a couple of efforts specific to just getting shovel ready projects on the shelf, as our DOT friends like to call it. Funding, always a challenge, but there's been this restoration technique is incredibly economically viable because the dredging is paid for through a completely different work stream than the habitat restoration kind of pots of money that are available. So we're able to leverage a little bit of public or private grant money to the hilt to match it with a dredging project, especially if it can happen simultaneously. So as the dredge material is getting dredged, it's getting brought straight onto the marsh. It's a very viable and exciting way to accomplish large-scale restoration and really lining things up. So we're planning projects together, and there's been a lot of progress, and there's a lot of work left to do kind of in that front. So we're really expanding the use and the practice of marsh nourishment through projects, through policies, and really considering this an important program in coastal management, especially with the Nature Conservancy as a key convener in that space. Yeah, I'm running low on time. Okay, so as I said, we've been learning by doing, and by aggregating others' experiences to create. So there's a set of, if you want to go deeper on this topic, a lot of the projects on that second gen map, we have a collection of case studies. I think Lily will share the link after this presentation. We had a great engagement over a couple of years called the Beneficial Use Learning Network. So there's a lot of videos and recorded webinars to help you understand kind of how these projects come together or dig deeper on some of the specific projects. So we'll share the link to where those are held as well. I've really been focusing on getting kind of everybody rowing together as far as agreeing to keep our sediment resources within the system and to manage them and maximize the amount of dredged material that's available for restoration. So that comes through regulatory agreement and understanding. That comes in a bit of a sea change in how our navigation managers are viewing marsh restoration as part of ways to use sediment or ways to dispose of sediment. And so the Conservancy was asked and very active asked to lead an effort by the New Jersey Department of Transportation to look at dredge sediment management in the Atlantic Coast back bays, and really get all the agencies to the table and agree on some key principles. So that was really foundational work that was completed a couple of years ago and has been just a great springboard for all of the collaboration and scaling work that we're doing now. Just kind of formalize everyone agrees this is the right way to do, the right thing to do. How are we actually going to do it? And so that's in that document. And this is really where our program sits right now. So creating this shared project pipeline around using dredge sediment to benefit salt marshes and keep them in place. And so again, we're aligning dredging need through those partnerships, marsh need through science tools, and working with landowners, and community needs as well, whether it's on the dredging side or on the resilience side. So what do communities need to be able to protect them, and how can nature play a role in that? Incredible partnership and a lot of active work. I say 50% of my meetings on any given day, pulling all of these actors together because there's just so much momentum and excitement and like promise from this work for our marshes. So all of those partnerships are resulting in an ever increasing marsh replenishment pipeline. So lining up projects that are on the dredging side with restoration projects, and really all coming together soup to nuts to make these projects happen in an efficient way. And this doesn't just happen in New Jersey. So I mentioned federal landowning partners, the Army Corps of Engineers. There's a lot of momentum for this practice all along the Atlantic coast. The Army Corps has a commitment to reuse 70% of their dredge material by 2030. So we say 70 by 30. That commitment is exciting and it's a wonderful opportunity. They view beneficial use as anything that's good that you can do with sediment. It's great that we're recycling. It's a good thing. We are hoping through policy interactions and government relations work and work on the ground on real projects to direct or expand, make sure that marsh restoration is a big portion of what they're doing with that 70% of their dredge material. And so that involves innovation, partnership, funding streams, and we're working on all of those things with our colleagues and our peers in other departments. So I mentioned government relations, our policy teams, also with our colleagues in other states. And I will end with that excitement, I guess, and pause for questions. Lily, if you'll help.
Sure. Thank you so much, Adriana, for that awesome presentation. So with the time we have left, we are going to open the floor for some questions. We have a couple in the Q&A box, but if any more come to mind, please feel free to add them, and we will do our best to answer them live. Any questions that we can't answer during this live session, we'll try our best to address them in a follow-up email that you can expect to see again sometime from us sometime next week. So let's see here. Okay, so we have a question here. It seems to me that for New Jersey marshes to persist, we will have to repeatedly put additional sediment on top. That would have to be done every X amount of years. Who would be willing to fund this?
So I think this is, yes, you're correct in many places. There's a lot of ground that we're making up with these dredge material projects, and the marshes themselves and the grasses actually have resilience. So they are also invested in their own survival. And so in some places we're getting this right, we're planning ahead, and the marshes can stand tall for a while, 15, 20, 30 years in some places. Other places, we will need to see repeated placement or cyclic kind of placement. This is where aligning it with the maintenance dredging of our channels is really exciting and provides that opportunity. So as this becomes oh my gosh, just the way that business is done, just the business as usual, for our navigation partners, they're funding that maintenance dredging. And if restoration is, if that maintenance dredging includes where they place the sediment when they're done. So it's not a perfect solution. And we do need long-term sustained funding for the restoration piece. But the resilience benefits and the habitat benefits, there are a number of funding streams that are available or that could be created. It's certainly part of the conversations we're having with policy to set up this repetitive funding stream. The good news is the maintenance dredging, which is the largest cost, is funded on a cyclical basis already.
Okay, great. Thank you. Next question here. Do you spray all of the dredged material at once or in phases?
It depends on the project. And so working with dredgers, we've been able to do some really innovative things. So you plan your marsh restoration project ahead of time. They have a sense of, okay, we need 10,000 cubic yards, which is, I've had to learn to speak in cubic yards. Um, that like we need 10,000 cubic yards of silt over here. We need 29,000 cubic yards of sand over there. They actually have technologies, the Army Corps of Engineers in particular has technologies where they can separate that material in real time, and make those differentiations. But um, it depends. So if an area is heavily contained, Avalon was heavily contained. We essentially like created a perimeter and pumped into it the way you would fill a bathtub. Um, that required a lot of starting and stopping, so that things wouldn't overtop. And so that's one of the benefits, I think, to having the dredgers at the table and talking to you about constructability and feasibility and kind of playing with things from the start as we're designing these projects. The ideal is there's no stop to the dredging. The dredging just happens and the restoration happens simultaneously. And there's a bunch of different technologies that can enable that. And by having them at the table earlier, we have become more successful at creating those nonstop kind of dredging opportunities. The other thing I'll say about the volume is some channels, like some dredging projects, generate a lot of material. And not every restoration project, we want to give it the lift it needs, but not necessarily have to go too high or too big. In planning these projects together, the dredger can actually select a portion of their full dredged network that they need to, that will be dedicated towards the restoration project, if that makes sense. So that's another way to deal with kind of varying volumes and make sure that we're right sizing these projects. As we look and plan ahead, ideally we line up the big projects with big projects and small projects with small projects. That's part of the excitement of having this shared pipeline and what we're working towards.
Awesome. Thank you. Next question here. Are there any known different considerations for tidal riverine marshes? Thinking of the Raritan River in particular.
There are. There's different tolerances. Every system is different. As we're developing and planning projects, basically, one of the first steps is to understand your tidal regime, and what the drivers are. And so we put out equipment to look at the water levels on the marsh, the water levels in that case in the river, and modeling groundwater as well. So groundwater wells, because most marshes, especially in riverine systems, you've got water moving across the land, kind of coming from the land towards the water, and then the reverse with the tidal influence. And so they're complex hydrologies, and all of that math and understanding needs to go into your design and making sure that you're reaching your outcomes. There's also some carbon sequestration differences, different plant communities, and things like that. I would say those are still newer applications, and a lot of our partners through the New Jersey Coastal Resilience Collaborative in the northern part of the state are really interested in applications kind of in our more urbanized or riverine wetland habitats, but not as many demonstration projects have been done in those areas. It's certainly an area for growth and expansion. In other places, in other states, in Maryland in particular, they've been doing these in riverine systems as well.
Awesome.
And Abbott's Meadow, I should say. Abbott's Meadow is like 300 acres. It's 150 acres that have been done up in the Delaware Bay, and that's more tidal fresh kinds of systems.
Great. Thank you. Looks like we have time for one, maybe two more questions here. So, in your experience, what types of roles or skill sets are most needed right now to effectively support marsh restoration and conservation efforts, particularly, particularly in the kinds of projects that TNC is leading?
It's a great question. Um, I really wish I would have taken some engineering courses. Um, so I think the skill set of being able to collect data in a targeted way, um, to do kind of a broad brush site assessment, and then be able to translate that to coastal engineers. So understanding dynamic systems like our salt marshes, and the right metrics, like right sizing the metrics, um, really directly contributes to restoration design. So I would say, and policy chops, right? So finding the right opportunity to, there's a regulation, there's this one thing that we need to tackle, and how being able to see how it kind of crosses, the whole practice, or enables the practice, or constrains the practice. So I think I was, a dyed in the wool biologist, right? So I'm out there measuring grasses, and but the remote sensing technologies have been incredibly powerful, and being able to amplify and understand systems as they're dynamic and across the landscape, is especially critical for organizations like TNC or DEP that are looking across the entire state for the best opportunities. Having good quality data that's reliable and being able to translate that towards restoration action, is really the most important nexus.
Awesome. And we'll do one more question. Are any other states using this technique?
Absolutely. So we are, if you look to the Gulf of Mexico, to the Gulf of America, to the Gulf, to Louisiana, um, or the West Coast, in California, there are, even the Great Lakes, there are a number of places where this technique has been used for a lot longer than it has been in New Jersey, at a different scale. So in Louisiana, they're actually mining sediment. Their wetland loss is astronomical. And so they're mining sediment the way we do for beach nourishment. They're just finding mud where they need it, and they're recreating wetland. A lot of those techniques are really transferable here, but the scale of their projects are tens of acres, tens of thousands of acres, whereas we're at hundreds at this point, with a good beat on thousands, of acres. And in California, same thing. So as we get along the East Coast, New Jersey, especially in the Mid-Atlantic and the Northeast, New Jersey's on the front lines. So these systems are heavily regulated and complex, and there's a lot of interface with human development and other uses of our marine and coastal systems that we have to navigate. But it's important to understand that this practice is happening nationwide, in many places where channels need to be maintained or navigation systems need to be maintained, in part because the places that they used to take that material are filling up. And so that's creating a lot of opportunity. That's where the opportunities that we have in New Jersey have come from. There were places where they couldn't get anything dredged, they couldn't clear a channel if they didn't if they weren't able to find a new place to put the material. And so those initial pilot projects kind of came out of that opportunity. So it started in an opportunistic way, and it's definitely expanding to a much more systematic and strategic approach.
Great. Thank you, Adriana. Would you mind going to the next slide because that is all we have time for today. Before we wrap up, I just wanted to quickly highlight two upcoming events that we're hosting in case you haven't gotten enough of the Nature Conservancy lately. So on May 14th, we're hosting a special screening of The Keeper, written by Hudson Valley-based writer, director, and National Geographic ocean hero, John Bowermaster. This 80-minute film takes a compelling look at a major local river, the people who love it, as well as some lessons about waterway overuse and resilience. After the film, guests are invited to join a Q&A session with the film director, experts from TNC, and the riverkeeper himself. And then on June 6th, please join us for Bobcat Bonanza to celebrate the New Jersey's bobcat population and the lands they depend on. This free event takes place at our northern office in Chester, New Jersey. Attendees can enjoy live music, ice cream, games, and more, all while learning about bobcats and TNC's work to protect the habitats they depend on to thrive. I'll be sending more details for these events in that follow-up email that I have mentioned, I think, 5 times at this point. Again, you can expect to get this email sometime next week. And with that, thank you so much, everyone, for tuning in to learn more about TNC's marsh restoration work in New Jersey. And thank you again, Adriana, for such an inspiring presentation. I hope you all enjoyed it and have a great rest of your day. Thanks, everyone.